All right, this is AP, AB, and BC Calculus. We're doing Unit 5, Section 4, which is using the first derivative test to determine relative, or local extrema. So the same disclaimer, don't use the word it when you should specifically refer to a function. So don't say it has a maximum, say f of x has a maximum. Don't say it is increasing, say f prime of x is increasing, or g of x is increasing, right? Be specific. So in 5.2, we learned how to find critical numbers of a function, right? And also to pay attention to included endpoints. In 5.3, we learned how to make sign charts to find when a function is increasing or decreasing. In 5.4, we're going to take both of those together, and we are going to use them to find the extrema of a function. So technically what you're doing here is called the first derivative test, but really it's just a logical extension of the skills that you've already used in those two previous sections. So finding critical numbers, making a sign chart, and then using those up and down arrows to get a basic visual gist for what's happening in the function, and that'll make it really readily apparent where there are maxima and minima. Okay, so moving on. So use the first derivative test to find all extrema of the function on the interval provided. Label each as a relative or absolute, and also as a maximum or a minimum. So I actually haven't defined relative and absolute yet, which is something I intended to do earlier, but somehow skipped, so we're going to talk about that now. Relative can also be called local. Absolute can also be called global. What it means to be a relative quantity is that it's the biggest or smallest around, okay? What it means to be an absolute max or min is that it's the biggest or smallest ever, right? So as an example, I could be the tallest member of my family, right? But anyone who's met me knows that I'm not all that tall. So if I'm the tallest member of my family, I might be a local max, but I'm not the tallest person in the whole world, right? That would be the absolute max or the global max. So now if you are an absolute max, you are also by definition a relative max, because relative max is basically any extrema, right? Any extrema minimum or max, the biggest or not the biggest, or the smallest or not the smallest. But absolute is specifically the very biggest or the very smallest, okay? So that's kind of the idea. And again, the word local is interchangeable with relative, and the word global is interchangeable with absolute. So as we walk through this, some of you might recognize that there is a chance that, that you wouldn't need any calculus at all to do this, and I'm going to show you how you actually could do example 1 just using your prior knowledge. But let's do it using calculus first. So first thing I need, if I want to find extrema, is I need to find the critical numbers, which is going to be when f prime of x is 0 or does not exist. So I find f prime. F prime is going to be 2x plus 8. Which means my critical numbers are either when f prime is 0, which is when 2x plus 8 is 0, so x equals negative 4. When f prime does not exist, which is not an issue because it's a polynomial. And then I have to pay attention to any included endpoints, which in this case are negative 5 and 0. So the numbers that need to show up on my sign chart are 0, negative 5, and negative 4. So on my sign chart, I only have the one factor, which is 2x plus 8. I have a negative 5. I have a negative 4, and I have a 0. So from that, I'm going to get f prime, and then I'll use f prime to sketch sort of a basic graph of what f looks like. So I know that 2x plus 8 is a line with a positive slope, meaning if it is 0 at negative 4, then any value before that will be negative. See how this is below the x-axis? And any value after will be positive, meaning that f prime is negative and then positive, so my f is decreasing and then increasing. So by visual inspection, you can see that this is definitely a min. In fact, not only is it a minimum, but it is by far the lowest point. There are no other contenders for minimums. Or minima, rather. See, I did that thing where I made it plural and did it wrong. So there's no other contender for a different minimum. So these are closed endpoints, right, because of these brackets. So that means that those included endpoints could also be extrema, and sure enough, they are both maxes. The question is which one is higher. So what I need to do, I know they're both max values. I need to figure out which one is the absolute max. In order to do that, what I'm going to do is I'm going to go ahead and write that there is a max at negative 5 comma blank. There is a max at 0 comma blank, and there is an absolute minimum because it is the only possible contender for the absolute minimum at negative 4 comma blank. So to find these y values, I need to use the original function, right? So I'm going to go ahead and start with f of 0 because it is by far the easiest. F of 0 is just a negative 3, or a positive 3 rather, because everything cancels out. 0, 0, positive 3. F of negative 5, right, is going to be a 25, right, minus a 40 plus a 3 which seems to be a negative 15 plus 3, so that's a negative 12, right? And f of negative 4 is going to be a 16 minus a 32 plus a 3, which seems to be negative 16 plus 3, so negative 13. So when I look at the two max values, I recognize that 3 is higher than 12, so the absolute max is at 3. Oh, didn't mean to extend that, my bad. All right. There we go. All right. So the absolute max is at 3, and the local or relative max is at negative 12. Now, some of you are probably thinking, okay, cool, Hogan, but this is a parabola. I could have figured that out in 2 seconds. And that's not false. So this was a particularly easy example. And if you look at our original f of x, which was x squared plus 8x plus 3, if I'm remembering correctly, let's go up and double check. All right, so you could have cheated and figured this out with algebra 2. If you had chosen to use algebra 2, you'd say, wait a second, I know this graph. This is a smile, which means that if it's a smile with endpoints, this has to be the min, this has to be one of the max values, and this has to be the other max value, and then you could have just plugged in and found them. And the way you could have found the min is you could have cheated and said, oh, I remember that the vertex is at negative b over 2a, which would be negative 8 over 2. Oh, hey, it's a negative 4, and you already know that this is the x value of negative 5, and this is the x value of 0, and that would get you to the same spot that we already got to. So could you use algebra 2 to do this? Absolutely. But the idea is that, so the idea behind this is essentially that you, I'm giving you an easier question and showing you how the calculus works. As we move forward, you won't be able to just use algebra to figure out stuff. Interesting side note, and I don't know that I've actually covered this, but this comes from calculus, right? Because if you had some f of x that is a parabola, ax squared plus bx plus c, and you want to know where the vertex is, well, the vertex is going to happen when the derivative is equal to 0, right? Because if you picture where the vertex of a parabola happens, it's where it has a horizontal tangent, right? The parabola has a horizontal tangent. So that would be when 0 equals 2ax plus b. So where we get the x equals negative b over 2a, we get that from calculus. You can also get it by averaging the points that you get for the roots in the quadratic formula. But side note, when you know calculus, it's a lot easier to logic your way through some formulae. All right, moving on. P1. So go ahead and give it a try. Again, if you wanted to logic through this using algebra, you can. The reason I'm going to caution you that that's a bad idea is because I'm giving you these easier examples so that you can learn the calculus skills when it's simpler, and then when we get to harder ones that will absolutely require the calculus, you won't be trying to use algebra for problems that you really need to use calculus. All right, so I'm going to go ahead and find my critical numbers first, right? So to find my critical numbers, I need where f prime of x is 0, so I better find f prime. So f prime of x is a negative 6x plus 6. So it's up to you. You can leave it as a negative 6x plus 6. You could factor out a 6 if you so choose. I don't care. So if you want where f prime is 0, that's going to be at 1, right? 6x equals 6. That's going to be when x is 1. If you want when f prime does not exist, well, that's not going to happen because this is a polynomial. And you also need to list endpoints if there are any, which in this case there are. There's a negative 2 and a 4. Now, once we're here, right, so we now know that these are the values that need to appear on my sign chart. Again, you could totally do this with algebra. We're going to walk through it in the calc way so that you know how to do these skills. So negative 2, 1, and 4, make sure they go in ascending numerical order. And the only factor I have is a negative 6x plus 6. There's my f prime, there's my f. All right, so this is a line with a negative slope, which is a little bit tricky for people, right? So that means that this value is going to start above the x-axis until it crosses 0, and then the line will cross below. So what's going to happen is I have that f prime is positive and then negative, which means my f is increasing and then decreasing. So this value is definitely a max, not just any max, but it's the absolute max because it's the only max value. These are both included endpoints, so both of these are mins, and which one is the absolute one will depend on which one's lower. So I have a min at negative 2 comma blank. I have another min at 4 comma blank. And I have a max that I happen to know is the absolute max because it's the only top value on the chart that I have at 1 comma 0. So to find all of those values, remember I'm going to go back and use the original function, right? So f of negative 2 is going to be a negative 3 times a 4, so that's a negative 12, minus a 12 minus a 4, that's a negative 28, right? F of 4 is going to be a negative 3 times 16, which is a negative 48, plus a 24 minus a 4. And that seems to be a negative 28. Okay? And then if I plug in f of 1, I'm going to get negative 3 plus 6 minus 4, which seems to be a negative 1. So both of the min values are the absolute mins because they're the same low value. They're both negative 28. It's the same value. They're both the absolute min. All right, moving on. So this is that cool side note that I actually mentioned, and I couldn't remember if I'd explained it to you before, but here you go. I did have a slide for it, that where we get the negative b over 2a thing. So you can either get it by averaging these 2 points here, right, which is what I had just mentioned on a previous slide because I clearly forgot I had made this slide, or you can get it by differentiating and knowing that y prime is 2ax plus b and then solving and get negative b over 2a. So you'll also find this in physics, that once you know calculus, physics is a lot easier. There's actually a reason that there is calculus-based physics and algebra-based physics, because once you have a foundation in calculus, you'll be surprised to realize how many physics formulae you can derive logically in your head. Not derive in the sense of differentiating, although sometimes that's true, but derive in the sense of like understanding from given information. All right, moving on. Okay, so we're going to use the first derivative test to find all extrema in the function, label as a relative max or min. So this is another one where you're probably looking at this thinking, Hogan, this is a really simple function. What are you thinking? So there are ways to skip to the end on this problem, and that's not cheating, but I want to show you how you would do this using calc and also how you could do it using logic. So the first thing I need to do is I need to find my critical numbers, right? So my critical numbers are going to be when f prime is 0 or when f prime does not exist, and I'm going to have to put endpoints on the chart too, right? So my endpoints are going to be 0 and 3. So I want you to look at this and realize that f prime of x is just a negative 5. So f prime can't be 0 because negative 5 equals 0 is a lie, and f prime can't not exist because there's no denominator to have equal to 0. So what that means is there are no critical numbers. There are no critical numbers on this window, not a single one. So the only things that would go on your sign chart are the 0 and 3. And again, this is sort of an intentionally unusual example because I want you to see what happens if things are crazy. So here's my f prime, right? F prime is literally always a negative 5. There's nowhere to even plug in. It's just always a negative 5, which means that f is always decreasing, which makes a ton of sense because look at what f is. F is a line with a negative slope. So this makes logical sense, which means that the max value is going to be the one at the start of the interval, and the min is going to be the one at the end. So the absolute max is going to be 0, comma, and then I'm going to do f of 0, which is 8, right? This was f of 0. And the absolute min is going to be at 3, comma, blank. Well, that's going to be f of negative 3, or sorry, f of 3, which is going to be negative 15 plus 8. That's going to be a negative 7. And that's it. Now, could you have logically figured that out if you look at this and say, wait a second, this is a line, it looks like this. That's it. Yeah, you could logically figure that out without calculus, right? And that's not wrong at all. Part of the reason I'm showing you some of these examples that are weirdly so simple that they seem really easy is because as you get better at the really hard examples, some of these really straightforward ones are going to seem really hard. So could you look at this and say, wait a second, this just looks like a line with a positive slope, which must mean that the min is at the left endpoint and the max is at the right endpoint. Would that be cheating? It would not be. So if you were able to spot that, right, if you made this mental leap, that's not wrong, right? If you made the mental leap that it looks like this, so the min is at negative 2, comma, blank, and the max is at 1, comma, blank, and they both have to be absolute because there's nothing else happening here. The graph literally just goes up the whole time, right? That's not wrong. That's okay. If you made that leap and then you would plug in the values, if you plug in a negative 2, you get negative 4 minus 3, so you get negative 7. If you plug in a 1, you get 2 minus 3, which is a negative 1. Great, totally fine. But we're going to walk through how you do it in a calculus sense anyway. So f prime would just be a 2, which means f prime equals 0 is not a thing because 2 can't equal 0. F prime does not exist is not a thing because 2 is not the same as does not exist. And you do have endpoints. You have endpoints at negative 2 and 1. So if you made your sign chart, those are the only two numbers that go on there, and you're making a sign chart where your f prime is literally just a positive 2. So you get that f goes up the whole time. And once you do that, sure enough, you get the same set of answers. You get that there is an absolute max at 1 comma negative 1. You get that there is an absolute min at negative 2 comma negative 7. And that's it. All right, moving on. So now it's getting a little bit harder. Now we have a cubic. So use the first derivative test to find all extrema of the function. Label it as relative or absolute and max or min. Okay, so now it's a little harder, right? I have f prime of x equals 3x squared minus x minus 2. My critical numbers are going to happen when f prime is 0, which would be when, and I'm going to go ahead and factor this now. I know it's going to be a 3x and an x. I want a negative 1 at the end, so I think it's a minus 1 and a plus 2. You should always FOIL to double check. 3x squared minus 3x plus 2x checks out, and that's a minus 2. Okay, so I'm going to get that x is either negative 2/3 or x is 1. So there's my two critical points from that information. The other kind of critical numbers are when f prime does not exist, but that's not an issue here because, again, there's no denominator, right? You can usually tell pretty quickly when f prime doesn't exist because it's when the denominator equals 0. And lastly, do I have endpoints? Yes, I do in this case. The endpoints are negative 2 and 2, right? And notice that both of these values fall in that window. So when I make my sign chart, I have a negative 2, a negative 2/3, a 1, and a 2. My factors are a 3x plus 2 and an x minus 1, right? And my f prime and my f. Okay, so 3x plus 2 is a line with a positive slope. So is x minus 1. So 3x plus 2 is going to be negative before it hits that 2/3, that 0 value, and then positive after. X minus 1 is going to be negative until it hits 1 and then cross to positive after. So I'm going to get positive, negative, positive, which means my f is going up, down, up, right? I know that there are included endpoints. So what I've got here is that I have a min at both negative 2 and at 1. I don't know which one's absolute yet, right? The only way to figure out which one's absolute is going to be to find the actual values of those, right? And I have max values at negative 2/3, negative 2/3 comma blank, and at 2 comma blank, right? So my job is going to be to plug in and find those values and see which ones are bigger or smaller. Now, there's always somebody that says, wait, couldn't I have made an easier f prime sign chart if I recognize that f prime, right? F prime is a smile, right? It's a parabola that's a smile, and I know that it's got 2 zeros, and the 2 zeros are at negative 2/3 and 1. So there's always somebody that says, hey, if I know that, couldn't I know that it goes like this, which means positive, negative, positive, and you'll notice that mirrors positive, negative, positive here. Absolutely. I don't care what sign chart you use. But either way you choose to do it, you're going to have to get to the point where you know that there is a min at negative 2 comma blank and another min at 1 comma blank. There's a max at negative 2/3 comma blank, and there is a max at 2 comma blank. Now I'm going to go ahead and take a quick shot of this particular function so that I can easily drag it down to the bottom and use it because I'm lazy and don't want to have to recopy it. So that's my function. Now it's up to you how you choose to evaluate these. You could just plug the numbers in. There's definitely nothing wrong with that. I think that collectively as a group, you might not want to do that when you get to the negative 2/3. I think a lot of people don't love fractions. So there's two ways to do this. You can either just straight up plug in, which is fine, right? If you wanted to find f of negative 2, one way to do that is to do negative 2 cubed, which is a negative 8, minus 1/2 of a positive 4, plus a 4, plus a 1. And if you do this, you get negative 8 minus 2 plus 4 plus 1, which seems to be negative 10 plus 5, so negative 5. That's fine. There's an interesting other option, though, if you wanted to use it. The other way to do that is to evaluate by using synthetic division, which some of you might have forgotten. You might not want to use synthetic division, and that's your prerogative, but I just want to show you that it's cool and it's faster in some ways. If I drop the 1 straight down, right, and I multiply, I get a negative 2. That's a negative 2.5. I multiply and get a positive 5, and I add straight down. I multiply and get a negative 6. Oh, look, there's a negative 5, and I think that went faster. Again, it's just up to you. Either way, I get a -5. When I plug a 1 in, I'm going to argue that 1 is pretty easy to plug in whichever way you pick, because it's just a 1 minus a 1/2 minus a 2 plus a 1. It seems that I get two positive ones that go with that -2, so I think I just get a -1/2 or a -0.5. Once I know that those are the two min values, I can go ahead and declare that the -5 is the absolute min and that the relative min is the -1/2 or -0.5. For the max values, I get that the -2/3 is the one nobody's going to want to plug in. F of 2 is not actually all that awful, right? It would be 8 minus a 1/2 of a 4 minus a 4 plus a 1, right? So that's going to be 8 minus 2 minus 4, so minus 6 plus 1. So I end up getting a 3 for the 2. So that one's not bad. The one that you're really probably not stoked about plugging in is the 2/3, or the -2/3 rather. So I'm going to argue that it's up to you, but I'm going to argue that maybe I want to do the -3rds with synthetic division anyway, or -2/3 with synthetic division anyway. I kind of like the synthetic division option, but if you hate it, that's your prerogative. It doesn't matter to me. It kind of depends on how you feel about fractions in general. Drop the 1 down, multiply. Now, the only part that you're going to hate about synthetic division here is you really need to get everybody in sixths, right? So I'm going to treat this as a -3/6, right? And I'm going to treat this as a -4/6. So I'm going to get -7/6. And again, you might not like this. This might get like way too ugly for you. I'm going to argue it gets just as ugly any other way that you choose to do it. When I multiply, right, I'm going to get a positive 14 over an 18. So I'm going to go ahead and cancel a 2 and make that a positive 7/9. This is a -18/9 because that's what -2 would be. So when I add straight down, I get -11/9, right? And when I multiply, I seem to get that this is a positive 22 over 27. Since this is a 27 over 27, that's going to end up being a 49 over 27 is what I think we should get our answer to be. So again, I get that that's not super fun, right? 49 over 27 is just a hair smaller than 2, which makes this the relative max and this the absolute max. The other way to plug in the -2/3, right? The other way to plug in the -2/3 would have just been to do f of -2/3 the old school way, right? If you chose to do that, it's going to be -2/3 to the third minus a 1/2 times this -2/3 squared minus a 2 times a -2/3 plus a 1. So this is going to be 8/27, right? This is going to end up being a minus 4/18, right? Which I'm probably going to cancel and make a 2/9 to make life easier. This will end up being plus 4/3 plus a 1. So you have 8/27. So I'm going to make everybody over 27. So that would make this a minus 6/27, right? When I times 9 over 9 here, I'm going to get plus 36/27, and then plus 27 over 27. When I add these together, I get 8 minus 6, which is 2. 2 plus 36 is 38. If I add the 7, that's 45 plus the 20 should be 6. Oh, no, that's not right. 65 over 27, which is not what we got the other way. So let's see what I did that was crazy. This is why nobody likes fractions. Let's see. That is -3/6. That is -4/6. That's -7/6. When we multiply, I can cancel the 2. And so I should get 7/9. I agree with that. This is a -18/9, which I agree with. That's a -11/9. I think that's a 22/27. I think that's right. Let's go back and check. Oh, because it's a -8. Mea culpa. All of that, and I told you synthetic division was easier. So that's a -8. So I get that this is -14. That's going to make that 22. Yep. That's right. It's 49 over 27. See, that's why synthetic division is easier. So I stand by my synthetic division idea that synthetic is easier. So all of that horrible number crunching was to get this information. All right, cool. Moving on. Okay, you're going to give P3 a try. So it's the same idea. You can certainly pause me if you want. So I'm going to go ahead and find my first derivative. negative 3x squared minus 6x plus 9, right? You don't have to take out a GCF of negative 3, but I'm going to. So I'm going to make this a negative 3 times an x squared plus a 2x minus a 3. I'm going to go ahead and fully factor this because I recognize that it's really likely I'm going to need to have the factored form to find all the zeros. Okay, so I want my critical numbers, right? That's going to happen when f prime is 0. Well, I can see just from having already factored that it's not when negative 3 equals 0, because that's a lie. But it is when x plus 3 is 0, so that's going to be x equals negative 3. And it's going to be when x minus 1 is 0, which is going to be at x equals 1. F prime does not exist is not an issue here because there's no denominator, and there are endpoints. The endpoints are x is negative 5 and x is 3. So what I'm going to need on my table are these 4 values. So on my table, I'm going to have a negative 5 as the endpoint. Negative 3 is the first of the critical numbers, then 1, and then 3. Right? My factors are a negative 3, which absolutely has to be on there because if it's not, it's going to screw up all your stuff. Right? And so my f prime, negative 3 is literally always negative. Right? And so that's important because it's going to change all the signs. If you have a leading coefficient, a leading factor rather that's positive, it doesn't do anything. But a leading factor that's negative does change all the signs, so be careful. So both of these are lines with positive slopes. So x plus 3 is 0 at negative 3, which means it's negative before it hits that 0 and positive after. X minus 1 is 0 at 1, which means it's negative before it hits that 0 and positive after. So 3 negatives make a negative, 2 negatives make a positive, 1 negative makes a negative. So what's going to happen is my f function is going down, up, down. So I have a max at negative 5, and I have a max again at 1. I have a min at negative 3 and a min again at 3. So my job is just to figure out which of those values are the higher and lower values. So the 2 min values, I have negative 3 comma blank, and I have 3 comma blank, right? And the 2 max values are going to be at negative 5 comma blank and 1 comma blank. So then it's my job to go back to this original function and plug in. Now, I'm going to argue that this one's a little easier than the last one, which is part of the reason that I made this the p problem and the other one the e problem, because this one doesn't have the stupid 1/2, and none of the zeros here, or none of the critical numbers here, have fractions. So it's up to you how you want to plug in. I am really strongly going to advocate that synthetic division is a great way to do this. The numbers get pretty big pretty fast if you're not using synthetic division. It's up to you. So I'm going to choose to find f of negative 3 by doing the synthetic division for these numbers. Now, you certainly don't have to. It's fine. I'm just advocating that this is faster than the plug-in. I drop the 1 straight down, I multiply, I add straight down. I multiply, I add straight down. I multiply, and I add straight down, and I get a negative 26. And again, you'd get the same thing if you plug in, right? If you plugged in, you would have gotten a 27 minus a 27 minus a 27 plus a 1. These two cancel out, and oh, look, it's a negative 26. You don't have to do it this way. I'm just advocating that it's a good idea. If I plug in 3, again, I think synthetic division is a really dope, super fast way to do this problem. If you're terrible at synthetic division, it's probably not, right? So like, know yourself. So drop it down, multiply, add straight down, multiply, add straight down, multiply, add straight down, and oh, look, it's a negative 26. So this is also going to be one of those situations where they're both the absolute min, right? So if they're both the same number, then they're both the lowest number. For f of negative 5, right, I'm going to go ahead and plug in negative 5 in my synthetic division. Again, you don't have to use synthetic division. You can just plug in the old-fashioned way. I just think this is easier. I multiply and add straight down, multiply, add straight down, multiply, add straight down. And then for the 1, honestly, for 1, you could do whatever you want. I don't care. F of 1 is pretty easy if you just want to plug in. You're getting a negative 1 minus a 3 plus a 9 plus a 1. That's a negative 4 plus a 10, so I get a 6. So it turns out that they're both the absolute max. So because they're the same value, they're both the absolute max, they're both the absolute min, and that's your problem. All right. So in this case, I'm only asking you for the x coordinates of all of the extrema. I just want to know if it's a max or min. I'm not asking you for the y coordinate, so I don't want you to find it. So f prime of x is going to be a 4x cubed minus a 6x squared, right? So f prime of x, if you choose to factor, right, I would suggest that you take out a 2x squared and you're left with 2x minus 3. So my critical numbers are going to be when f prime is 0, right? So 2x squared equals 0. That's when x is 0. Or when 2x minus 3 is 0, which is going to be x equals 3 halves. F prime does not exist is not a thing that's going to happen here, and there are no endpoints here. So the only things that go on my sign chart are the 0 and the 3 halves. So on my sign chart, well, and the infinities, right? So if there's no endpoints, you do need to go to infinity because things happen after 3 halves. Things happen before 0. So on my sign chart, I'm going to use 2x squared as a single factor. You don't have to. The other way to write this would be a 2, an x, and another x. Like you could really, truly factor it all the way down. I'm not going to. So I know 2x squared looks like a parabola that just touches the axis at 0 and goes back up. So it's positive all the time except at 0. 2x plus 3 is a line with a positive slope, so it's going to be negative before it hits 0 and positive after, which means that my f prime is going to be negative, still negative, and then positive. So I'm going to get that f is going down, down again, and then up. So the min is here, and there is no max because these go up forever, right? So there is no max. There is a relative min, which also for the record happens to be absolute because you can see there that it is the only min at x equals 3 halves. It is also absolute in this case. They're not always also absolute, but in this case it is also absolute. This thing right here is what we call a saddle, right? We've talked about that a little bit in previous videos. Interesting side note, see how this is a double root? See how you would, if you were solving this, you'd get x squared equals 0, which means that technically x is 0 or x is 0, like that root happens twice. Double roots, like any root that happens an even number of times, gives you a saddle. So if I give you something like x minus 2 to the 8th, that's going to be a saddle. So let's say f prime had this, there'd be a saddle at x is 2. Because this is an even power, not because of the 2 on the inside, but because it's an even power. So just sort of an interesting side note about the more of these you do, the more likely you will be to see patterns like that. All right, so you go ahead and try P1. Again, I'm only looking for the x coordinate. Don't do extra stuff. So I'm going to go ahead and walk through it while you walk through it. You feel free to pause me if you want. 3x squared minus 6x plus 3. So I'm going to get that f prime of x is a 3 times an x squared minus 2x plus 1, or a 3 times this thing happening twice, right? You can either write it this way or you can write it as squared. So my critical numbers are when f prime is 0. Well, that's either when 3 equals 0, which is a lie, or when x minus 1 equals 0, which is when x equals 1, but it is worth noting that that is a double root. It happens twice, right? That's a double root. It happens twice. That's the only critical number that I'm going to have because f prime does not exist, is not an issue for a polynomial, and there are no endpoints. So on my sign chart, I'm only going to have x as 1. When I list my factors, you can either list them as 3 separate factors or you could make the x minus 1 quantity squared. I don't care. What's important is that these two together are going to net positive because they're the same factor twice. So although they're both 0 at 1, they're both negative before 1 and positive after, meaning the two of them together will net positive. So what's going to happen is that my f prime is going to be positive, 0, and then positive again. So my f is increasing, levels off, and increases again. There is no max. There is no min. This thing will go down forever. It levels off for a sec at a saddle and then goes up forever. Like that's what this is going to look like. There's no max. There's no min. All right, let's go ahead and do this again. We're doing E5. We are only finding the x coordinates. So again, I am going to have to use the first derivative. So u, this is a product rule, right? U, and there's my v. So u dv is going to be e to the stuff times the derivative of the stuff because of the chain rule, plus v, which is e to the 2x, du is a 3. So my f prime of x is going to be a 6x e to the 2x plus 3 e to the 2x. I'm going to go ahead and factor out a GCF of 3e to the 2x and be left with 2x plus 1. So when I want my critical numbers, and notice that in every one of these problems I've done, I have labeled clearly that I'm finding when f prime is 0. That's going to be a point on your AP. You need to communicate that information. So either 0 equals 3e to the 2x, but that's a lie because 3e to the 2x is always a positive number, or 0 equals 2x plus 1, x is negative 1/2. That's my only critical number. There's no places where f prime does not exist because there is no denominator, and there are no endpoints in this given problem. So the only thing going on my sign chart is the -1/2, and then the infinities on either side. So my factors are a 3e to the 2x, and you can put the 3 separate if you want, or you can put it with the e to the 2x, it won't really matter. E to the 2x is always a positive number, so 3 times a positive number is always positive. This guy is aligned with a positive slope, as we've seen like a bajillion times, so it switches from negative to positive, which means my f prime is negative and then positive, so f is decreasing and then increasing. So there is a min, right? So the only value we have is that there is a relative, and for the record, it's also absolute, but you weren't asked that. There's a relative min at x equals -1/2, and that's all you were asked to find. You were not asked to find, you're not asked to label it as absolute. You're not asked to find the y coordinate. All they want is the location of the relative minimum value. Oh, and there's no max. Since it said find, it said label each as a relative min or max. That's the only point. There is no max. All right. P5, same idea. Again, you have a product rule. Please feel free to pause me if you so choose. So f prime of x is going to be u. dv is going to be e to the stuff times the derivative of the stuff plus v, and then du is just a 4. So I'm going to get a -4x e to the -x plus 4e to the -x. I'm going to yank out a negative e to the -x and be left with a, oh, sorry, a -4e to the -x and be left with an x minus 1. You didn't have to yank out the negative. You could have yanked out a positive. It doesn't really matter. So when I go to find my critical numbers, and again, notice that I'm communicating what I'm doing in every step. I'm not going to lose a point on the AP for lack of communication. So 0 equals -4e to the -x. Well, that's a lie, because this whole thing is going to be a negative number, right? E to the stuff is positive. -4 times that thing is going to be negative. That's a lie. So the only critical number I get is when x is 1. That's it. There's no places where f prime doesn't exist, because sure, you could actually flip the e to the -x down to the bottom and make it an e to the x, but e to the x can't ever be 0, so the denominator would still never be 0, and there are no critical values for f prime not existing. So on my sign chart, I make sure I have a negative infinity and a 1 and an infinity. I need the -4e to the -x. Again, you could split it up into 2 factors, and -4 times an e to the -x separate factors, or 1 factor. I don't really care. Either way, this thing is negative all the time, right? So I'm going to erase for a sec. Ooh, I used the giant eraser and forgot. That's all right. This thing's negative, right? And then this thing is aligned with a positive slope. So it's 0 at 1, negative before 1, and positive after, right? That means that my f prime is positive and then negative, which means f is increasing and then decreasing. So I have a max. So the only coordinate I have here is a relative, which also happens to be absolute in this case. But again, you're not asked that. Max at x equals 1. And again, I was not asked for the y value. I should not do more work than is requested of me. All right. So same idea. Remember that this f of x is actually the quantity sine of x, whole thing squared, right? So what's going to happen is that I need to find f prime, which is going to be 2 sine of x to the first times the derivative of sine, which is cosine. Now I need those critical numbers, right? So my critical numbers are either when f prime is 0, which is going to be either when 2 equals 0, that's a lie, when sine equals 0, which in this window is going to happen at the pi's, so that's going to be x is 0 and pi and 2 pi, right? Or when cosine is 0, which in this window is going to happen at pi over 2 and 3 pi over 2. I could have when f prime does not exist, but again, sines and cosines don't have a denominator, so it's not an issue. And then I do have endpoints, but they actually were already mentioned for the record, so I'm just going to point out that they're already there. So I have ends. So now when I make my sign chart, there's a lot of them. 1, 2, 3, 4, 5 lines. 2, 3, 4, 5. Great. Close enough. My factors are a 2, a sine x, and a cosine x. This is f. This is f prime. Sorry, f prime and f. I said them backwards. You get the gist. So I have a 0, I have pi over 2, I have a pi, I have a 3 pi over 2, and I have a 2 pi, and there's nothing after 2 pi, right? 2 is always positive. Now, I'm going to argue that you know sine is the y in the unit circle and cosine is the x in the unit circle, and each one of these divisions happens to be a convenient quadrant, right? Like 0 to pi over 2 is quadrant 1, where both of these things are positive. right? I know sine is 0 at all the pi's. I know cosine is 0 at all the pi over 2's. So in this window, I'm looking at quadrant 2, where the sines are positive but the cosines are negative. In this window, I'm looking at at quadrant 3, where everybody's negative. And in this window, I'm looking at quadrant 4, where the y values are negative but the x values are positive. So f prime is going to net positive, negative, positive, negative, right? So f is going up, down, which means that I have mins at 0, pi, and 2 pi, and I have max values at pi over 2 and 3 pi over 2. So my job is just to find out which, like whether there's mins or maxes that are bigger or smaller. So the mins are at 0. Oh, never mind. Look at me doing work I didn't have to do. That was literally all I'm asked to do, right? So I'm going to go ahead and list, right? See, I was about to find the y values because I didn't follow my own instructions. Sometimes we get on autopilot and we don't pay attention to what we're supposed to do. So there are min values at x equals 0, pi, and 2 pi. There are max values, right, at x equals pi over 2 and 3 pi over 2. And I don't know if they're absolute or relative because I don't care, because that's not what I was asked, right? And that's really hard sometimes, but that's where we're at. Okay, moving on. All right, so P6. Let's go ahead and bust out our first derivative. Come on, pen. Okay, cool. So we get a 1 minus 2 sine of x, right? So if we want our critical numbers, right, those are going to happen when f prime is equal to 0, right, which will be when 0 equals 1 minus 2 sine of x. That's when sine is a half, right, which is the y on the unit circle. So that's here at pi over 6 and here at 5 pi over 6. Right, so that's the only two spots in that window. There are no places where f prime does not exist because there's no denominator, but there are endpoints that should show up on my sign chart, which are 0 and 2 pi. So when I make my sign chart, I have a 0, a pi over 6, a 5, pi over 6, and a 2 pi. My only factor is 1 minus 2 sine of x, right? That's it. So there's not much I can do about it. So again, it's helpful to consider what window you're in, but what's tricky here is that you don't have any values on the unit circle between 0 and pi over 6. Like, there just aren't any. That's a 6, by the way. So on the next window, you're looking at a pretty decent sized window chunk here, so you could just try pi over 2 to plug in, right? And then the next chunk is a really big window. It's this entire thing, so you could pick pi or 3 pi over 2 or whatever. So I'm just going to pick pi. Okay, so the honest trick here is that it's really hard to pick an easy value in this first window, but generally sines and cosines, they're wave functions, so you'll often see that they switch sign at every possible 0. So sometimes you make an educated guess, or you kind of logic through it. So let's do the easy ones first. If I were to plug in pi here, because that's what's right here, right, pi, I would get that this is 1 minus 0, so that's just a 1, which is positive, right? If I would plug in pi over 2, I would get this a 1 minus a 2, which is a negative. And so I can make the pretty educated guess that this first window is positive. The other reason that that makes logical sense is that in this window that you're looking at, the y values are less than a 1/2. Like, you can see that because this is where y is a half. So the y values are less than 1/2, then this number is going to be smaller than 1, like negative 2 times that number. So this is going to net positive. So once you know that, your f prime is going from positive to negative to positive again. Then your f is going to go from this endpoint up and then down and then up again. So you can see that the two min values are going to be the included endpoint 0 and also at 5 pi over 6. So I'm going to have a relative min at x equals 0 and 5 pi over 6, right? And I'm going to have a relative max at the other two critical numbers. You can see that this is a max and this closed endpoint is a max. So I'm going to have a relative max at pi over 6 and 2 pi. And that's it, right? So that's all I'm asked to find. Moving on. Okay, so sometimes you're going to be given a table. So E7, use the first derivative test to find the x coordinates of all extrema. Label each as a relative max or min. So here's the trick. They gave you the sign chart. You were given an f prime of x sign chart. Okay, we are told that f prime is defined only on the window from -3 to 5, so this is the entire window. and they gave us a sign chart. It's this middle row. So based on that sign chart, sorry, I'm terrible at circling things. If you need to copy it, you can, but I'm not going to bother because here's the idea. If f prime is positive, right, f is going up, then down, and then down again, right? So what we're looking at is a graph that essentially has a max at x equals -1 and has a saddle, which is neither, right, has a saddle at x equals 1. And then this will be a min, and this will also be a min because our graph goes like this, essentially up, down, level, down again. So we don't know details about how high or low values are. I mean, you certainly can see that there is only the one max, but so basically I have a relative max, which will also turn out to be the absolute max, but that's not really relevant because we weren't asked that, at x equals -1, and I have relative min values at both endpoints. At x is -3 and x is 5. So you were not asked, but in case you're curious, at x equals 1, we have what's called a saddle. It is neither a max nor a min. It's called a saddle. All right, so when people see these table questions, sometimes they panic as though these are really, really hard questions. But in actuality, you were given the sign chart that you would normally spend a considerable amount of time making, and it was just handed to you. All right. Now, this is tricky, a little bit harder in P7. Give it a try, but notice that we're defined on the window from -5 to 5, but the table is only from 0 to 5 because f is an even function. So think about what it means to be an even function. Even function means symmetric about the y-axis, right? So like x squared is an even function, right? So this is an example of an even function. It looks like this, right? So basically it means that you could fold over the y-axis and have the same graph. So again, we are handed an f prime sign chart. And if you want, you can actually copy it down here and see what's going to happen, right? So here's 0, here's 1, here's 3, and here's 5, right? So because this is even, it's going to behave exactly it's going to behave essentially symmetrically on the other side. So there's -1, -3, and -5. Okay, so, and we know that these are our endpoints. So if we were to look at f prime, right, here's what we know. We know that from 0 to 1, f prime is negative, meaning that what f is doing is going down, right? Then from 1 to 3, f prime is positive, meaning we're going up, right? And then from 3 to 5, f prime is negative, meaning we're going down, right? So it's going to do exactly this same zigzag, right? So this same like zigzag that it does here, it's going to do on the other side. So it's going to look like this, down, up, down. See how that's symmetric? Like this is my this is my axis of symmetry. So I'm asked to identify maxima and minima. Well, once I sketch this little graph, it's pretty obvious that the min values happen here. So there are going to be relative minima at x equals -5, -1, 1, and 5, right? And then if we, in another color, highlight these maximum values, right? They're going to be relative max values at x equals -2, sorry, that's not a 2, it's a 3. My own handwriting is terrible. 0 and 3. And that's it. Okay, and again, I wasn't asked to find the y values, I was just asked to find the x coordinates. All right, so moving on, because I know this has already been a very long video. So how could you possibly so how could this show up on a calculator required section? So you might be given an equation for f prime as something that is way, way, way too ugly for you to graph it by hand, something that you can't make a sign chart for, right? And you might be asked to find the coordinates of the extrema, right? So so when I say extrema, and we'll say local extrema, for f of x, right? So you won't have the f of x equation. You'll have f prime of x. So if you have to do that, you're going to put f prime in as your y1, and to find your critical numbers, you're going to use second calc 0, right? And you're going to look for places where y1 does not exist, which would be like a vertical asymptote or a hole on the graph, which doesn't really happen all that often. So the graph you're going to see is your sign chart, right? When f prime is greater than 0, it's going to be the given graph that's above the x-axis. When f prime is less than 0, the given graph is going to be below the x-axis. So you can use this visual sign chart to see what f of x, the graph you can't see, is doing. Anyway, so, and then you always want to justify your answer in terms of f prime of x. So we're going to go ahead and walk through a couple of calculator problems really quickly. I know this has already been one of our longer videos. So calculator required. We're given f prime of x, and we're asked to find the x coordinate of all extrema of f of x, and then describe as a local max or local min. Okay, so I'm going to put this in as y1 in my calculator. This is not the thing that I had in my calculator before, so let's go ahead and, okay, so x squared e to the, and then this is going to be cosine of 2.1 plus x, close the parentheses, minus a 10.3. Cool. So let's double check. Oh, I need another parenthesis for the exponent. My bad. Okay, so you should always double check when you have something complicated like this. So x squared is correct. E, and then in parentheses, the whole cosine, everything is in that set of parentheses. There's an internal parenthesis set for the 2.1 and the plus x, and then we have a minus 10.3. Cool. Okay, so this is my y prime. So, or sorry, my f prime. So it's worth noting that you're putting this in your calculator as y1. You write that for your benefit. Calculator syntax isn't for the AP's benefit, it's for your benefit. Sorry, my bad. I made that giant and didn't mean to. Cool. Okay, so if we just make that slightly closer to the right size. Okay, so let's zoom 6. We're going to assume the standard window works. Okay, so here's the graph I can see. Okay, this is what I can see with my eyes for f prime. Okay, so that's what I'm seeing with my eyes. So remember, this is your f prime sign chart. Okay, so what's happening here is that these are my critical numbers. Okay, so there are four critical numbers, okay? And I'm just going to call them A, B, C, and D for the argument of this video, okay? To find them, I'm going to do second calc 0 because I need to find those specific values, okay? Now, what you'll notice is that, again, this is the physical sign chart. Like, this visual is a sign chart for f prime, okay? C and D, okay? What's happening here, if this is my f prime sign chart, is that anywhere that this graph is above the axis, right, anywhere here, here, and here, f prime is positive. So before A, f prime is positive. Between B and C, f prime is positive. And after D, f prime is positive. But anywhere that the graph is physically below the x-axis, well, those are places where f prime is negative. Because again, this physical graph is f prime. So what that means is that my f is going up, down, up, down, up. Now, since these are not endpoints, like this goes on forever and this goes on, like other stuff's happening this way, but it goes on forever, right? So this graph doesn't have an end. I have a max and a min and a max and a min, and that's it. So I'm going to have relative max values at x equals whatever I call A, and I'm going to put an approximately symbol, so in my brain I'm going to be like, hey, that's A, and whatever I call C, right? And I'm going to have relative minimum values at whatever I call B, right? Like whatever B is, and whatever D is, right? So D. It's not a bad idea to think of it this way, and then even if you ran out of time to find this on a, like, you know, if you ran out of time, you could technically say, hey, at least I understood the concept. So second calc, 0 is 2, right? Now, I always work left to right. You certainly don't have to do that. I do it because that way I know that I found each individual one. So remember, when you find a 0, you're going to go directly above, right? So sorry, to the left, to the right, and then hit guess. Okay, so that's the first one, right? I'm just going to take some screenshots. Second calc 0 again. And now I'm just going to work my way. So I'm to the left of the 0. I'm going to work my way over 1 0 at a time. I'm to the right, and then I guess. There's the second one, okay, and then second calc 0, and you can just see it takes some time, but that's the idea, right? So your calculator does the heavy lifting of finding the numbers, but you have to do the comprehension, right? So your calculator doesn't do the thinking for you. It only calculates the numbers, right? So second calc, we're almost there, 0, and then this is the last one. And you could zoom out to verify that this thing doesn't cross again, but it doesn't. So if you were nervous that you were going to miss an answer, you could certainly zoom out and verify that it doesn't cross again, but it doesn't. So those are my answers, right? When I give my answer, and this has been a sticking point for some people a lot, right? When I give my answer, we want to make sure, so there's one, I want to make sure I give 3 places after the decimal. If you give 2 places after the decimal, the AP will mark it wrong and you will be frustrated. There's the second one, there's the third one, and here's the fourth one, right? So when I give my answers, I need to say that my A was negative 5.288, right? B was negative 4.290. Notice I'm making sure to put them at the right spot. C was negative 9, my bad, 5, and either 6 or 7, depending if you round or truncate, right? Either answer would be right. Don't write both. And then D was 2.851. Okay, so those are my answers, and I labeled them as max or min. So again, you're using your calculator to graph this, and then the graph is your visual sign chart. Okay, so go ahead and try a P8. And again, I know that this video has already been fairly long, but you know, these are skills that you're going to need to have on a test. So so go ahead and try this. Oh, make sure, I didn't mention this before, make sure you're in radian mode. You never, ever, ever want to be in degree mode on a calc test. AP Calculus is done in radians. If you're simultaneously in an AP Calc class and a physics class, then you have to pay a lot of attention because you will frequently end up switching between the two. That is a 0.4. So 0.4 x squared in the exponent, and then plus a 1.2x minus an 8.13. And then we're going to assume zoom 6 most of the time unless you're told otherwise. Cool. So I'm going to double check. I'm going to zoom out a little just to make sure that this is the only time that this thing hits anything, and it seems to be. So we'll go ahead and go back to zoom 6. All right. So this is what I'm looking at, and remember that this, right, this value is my f prime, right? So I put this in as y1, which means these are my only two critical numbers, right? So I'm going to call them a and b, okay? So f prime of x equals 0 only at x equals a and x equals b. So those are my only two possible values. If you need to make this sign chart, it's fine. F prime is physically above the axis, so it's positive. Then it's physically below the axis, so it's negative, and then it's physically above the x-axis again, so it's positive, which means that what f is doing is going up, down, up. So this is a max, this is a min, and that's all I've got. So there is a relative max at x is approximately, and then I'm going to find whatever a is, right? And there's a relative min at x is approximately, and I'm going to find whatever I called b, right? So that's the idea, right? So I'm going to go ahead and do second calc 0, right? And I'm just going to go one at a time. Went too far. So I'm to the left. I cross the axis. I'm now to the right. I hit enter. There's the first one, right? And then I'm going to do second calc 0 again. And again, you're not finding these numbers by yourself. So you have to use a calculator for this. You have to be prepared to use a calculator for this skill. Cross the axis, and then guess, and there's my other one. So remember, always 3 places after the decimal, always in radian mode. There are a few like non-negotiable things. So there's the first one, there's the second one, and so then my answer, right, so A was a negative 2.00, either 2 or 3, I would take either, right, and this is a 1.45, either 8 or 9. Again, either answer is fine. You can round or truncate. Okay, cool. Okay, so same skill as an E8 and P8, but here you're not going to be using a calculator. Okay, so here we're given the graph. So notice that this is f prime. We are asked to find all of the critical values of f of x and label them as a relative max or min. So remember, this is your f prime sign chart, right? Anywhere that f prime is above the axis, right? So here and here, f is increasing, right? So f prime is positive, right? Because it's above the y-axis. And down here, f prime is negative, right? Because f prime is this physical graph. So if I were looking at this like it was a sign chart, the only critical numbers are at -1 and 1, so -1 and 1, right? My f prime is below the axis before -1. It is above the axis until 1, and then it's above the axis again after. Sorry, that's f prime, I wrote f, which means that what f is doing is going down, up, and up again. So we have a min and a saddle. Since there are no endpoints, there is no max. So there is no max. There is a relative min at x equals -1. And you weren't asked, so you were not asked, but for the record, there is a saddle at x equals 1. So this is the only thing you were asked to do. All right, cool. last one, and then that's it for this very lengthy video. So same idea. Again, this is f prime, so your eyeballs are making the sign chart. So anywhere that this graph is physically above, right? So in these windows, f prime is positive, and in these windows, f prime is negative. So if you don't need to make a separate sign chart, if you can just see that with your eyeballs, that's great. You can draw your f graph down here. You can say, look, these are my critical numbers, right? So down here, you could say, look, I get it. Here are my critical numbers, right? These are my critical values. F prime is negative, positive, more positive, and then negative again, which means that F is going down, up, down. So you have a min. So again, if you need to see that a little bit better, I'll go down a smidge, right? So we have down, up again, and then down. So again, I was a little bit off there, but that max would happen at this critical number, and that min would happen here, and there would be a saddle at this critical number, right? So if you did this, right, you would have a minimum, so you'd have a relative minimum at x equals -4, right? That's a min. And again, the logic there is that f prime switches from negative to positive, right? So you're explaining in terms of f prime, like what can you see with f prime? There is a saddle, which you weren't asked, but it is a saddle at x equals -2 because f prime goes from positive to still positive, right? And there is a relative max at x equals 3. And again, the reason is f prime goes from being positive to negative, right? So if you're explaining your reasoning, you're explaining it in terms of f prime. So that's it for our super duper lengthy video on how to use the first derivative test. I tried to give you a bunch of different examples of different ways that you could have to do it. Again, one of the things I want you to notice is that the most tedious examples were the ones where you actually had an equation and you had to differentiate. But inexplicably, people flip out when they see problems like this one, but you're handed the sign chart, right? So as much as this looks daunting when you see this crazy table, they're handing you a sign chart, right? As much as it looks daunting when you're handed this graph and you think, well, that's not the graph I want, what am I supposed to do? Again, they're handing you a sign chart. You just have to know how to read the graph. All right, so that is it.